Welcome to this session. It's towards the end of the day. Nice outside, so you have a choice. Why are we here? We're curious by nature. That brings us to conferences like this, and also what brings us to the IT industry. If I may ask, how many of you? I cannot control that, unfortunately. So how many of you, if I would ask you, would identify as professional developers who do that? I would say that the majority. So if we think about it, we learn things in conferences, we learn all the new things. But on Monday, after this conference, we go back to our daily job. And there we have to look not just what we do in the future, we have to look at what we can do today. So what we'll aim today is keep things on the practical side. And not just because we're in a Java conference, let's put this out of the way. Yes, you can build GenAI application in Java, and you don't need Python for that. So while Python is the preferred language in AI/ML, because traditionally people build AI/ML models and applications in Python, Java is the dominant language of the enterprise. So let's put this aside. SpringAI is in GA, the latest Google models for Gemini support, and there's a new SDK released 2 days ago. Everything supports Java at this time. So let's think that we invested in our skills, we learned things. Why don't we add the incremental skills to build GenAI applications? We don't need to use to change the stack or use a different language. So we want to walk from workflows to agents and see what capabilities agents would bring, and think that we might have heard about new things like MCP, and they're not just for tools only. And how should we build a RAG platform if we're an agentic RAG platform, if we're doing day-to-day work in the enterprise? Now, it might be easy to get into building GenAI applications, but are there any pitfalls? So we should always think about what can happen when we go with our applications to production. I'm Dan Dobrin. I'm an enterprise architect, part of customer engineering in Google Cloud. I focused in the last couple of years on building GenAI applications and code-assisted tools. I come from the app world. Before Google, I worked at Spring with the Spring team at Pivotal VMware. And outside of GenAI, I'm focusing on event-driven architecture, serverless, Java performance. Let's not forget, when we deploy our GenAI applications, we still deploy them in the cloud. What we learned, how we're going to deploy in serverless or a Kubernetes environment, still stands. We're just building on top. So let's create another distinction: workflow versus agents. You heard about these terms sometimes used in combination or sometimes interchangeable. I see workflows as systems where the LLMs and the tools are orchestrated through predefined code passes, like a state machine. We know the output, it's the input to another step. But agents, we see them as systems where an LLM will dynamically and autonomously direct their own processes and tool usage. So they will retain the control over how they accomplish tasks for the goals which we have set for them. So how are we going to explore this? I built a new application. It is built in Java 21. Yes, uses Spring AI GA, the latest Gemini models, the latest Flash preview announced 2 days ago at Google I/O, as well as the latest Pro from 2 weeks ago. And it will allow us to explore things like tools and RAG and agents and web search, different ingestion methods for our application, and retrieval methods. We can do filtering. In the enterprise, performance matters, safety, and we want to see always how these models sync. The application is built with the Vaadin framework. It is all Java, and the backend is an AlloyDB database, which stores not just our data but also our vector data. It is integrated behind the scenes through the Google backbone with Gemini model, and you get better performance for that. So if we think about it, how should we work with it? So we are going to ask, what is the capital of Spain? If you don't see it well, I can increase the font. Okay. So if we think at the workflow, we are thinking that we can have multiple pieces of code and execute different steps, but we can also ask, write a brief report about Berlin's population. So before responding, first summarize the report and then provide both pieces of information. So we're asking very distinct things. Write a brief report, summarize it, bring them all back. This is very much known to us. So this is how we're going to explore everything we do today. Now, how do agents work? What are they going to do? They work in an environment, and they have a decision-making component where they process information, evaluate options, and select actions. They are working with autonomy. Very important that they retain the autonomy as how they are going to accomplish the goals we set to them. So an agent would perceive environment as well as human input, work towards the goal we set for them, act on the environment to accomplish the objectives, and constantly learn from experience as well as human feedback if there's a human in the loop. Now, they have a number of key characteristics. So what do we expect? We expect them to think, to process information, analyze the environment, then plan strategies to achieve these goals, the goals set to them efficiently, act upon the environment to take action whenever there's a change in state, and continuously evaluate outcomes and learn from the environment. Now, how do agents evolve? How should we think about them? 2-3 years ago, we started with APIs with an LLM, very specific thing. Here's a prompt, an LLM, we get a response. Then we moved on to static agents, which you could construe as a workflow where we have a number of static steps to solve a known problem. Then we moved into dynamic agents. That's the sweet spot today, where LLM decompose a complex task and they iterate until they reach this criteria of done. And then there's, more or less with an eye on the future, a mixture of agents where multiple agents will collaborate to solve novel problems. Now, APIs with LLM provide a specific behavior. Static ones will solve problems which we know upfront about. Dynamic ones will solve ambiguous problem when we set up a goal, but we know the problem. It's just how this will be achieved is ambiguous to us. And a mixture of agent, it will help us now and in the future to solve ambiguous problem we don't know about. So we're moving from a less complex to a more complex environment, and as well from a more deterministic to a less deterministic one, the more the uncertainty. Now, as we build these systems, as these agents evolve, we have to realize that a complete solution can incorporate less complex solutions. What is the current production-ready reality? APIs with LLM mature, widely available, excellent for clear tasks. Static agents are the sweet spot for many production applications. Power of an LLM combined with RAG or known workflows. Dynamic agents should be used selectively for specific but well-scoped problems where the dynamic decision-making will outweigh the risk of the non-deterministic behavior. Mixture of agents are a work in progress. They're not ready yet for production, so we'll focus today on dynamic agents. So what capabilities would we expect? Well, we start from planning to create and evaluate a multi-step sequence of actions with a chain of thought for step-by-step reasoning, a process for breaking down complex tasks. Then, if a model that does not have the ability to get all the answers, we might be able to enhance an agent has not have enough capabilities to enhance that by providing a number of tools which could execute specific functions to complete the task. Then there's reflection. We have to evaluate data. We know how to test data in the past, but now we have to think, what does it mean? How do we test data? How do we evaluate constantly the response we get? And then there's multi-agent collaboration. Now, these agents would work in different types of flow. One would be sequential. Tasks can be chained together, a sequence of steps, very clear about them. We don't talk about the communication between them. It's how these tasks would be executed. Now, there are parallel flows where tasks can be decomposed into dependency-free, discrete steps which can be run in parallel. Think you want to run a credit check against every credit agency before giving somebody a credit card, and you can run these steps in parallel. Now, there are conditional flows where we want an LM to route the next step to one or the other step. And then there's constant evaluation. Let's think about it. We ask a number of questions, we get responses. Did they satisfy what we want? Should we continue? It's this loop where we would constantly evaluate. And last would be orchestration flows, where usually an LLM dynamically break down tasks and delegate to appropriate workers for different tasks. That's the one which we're going to build. So for function calling, how does function calling work? It started with function calling, now people call it more like tool calling. Let's stick with the function calling. A user would ask, what's the population of Berlin in 25? So the Gemini application would ask the LLM, and it would say, hey, here's this prompt, but here are a number of known function contracts which you can call in case you need them to answer this question. An LLM might decide, well, please call get population with this particular city for me. It would call, the app can call the get population service. Could be an external API, could be a service, could be a model context protocol server, which would give us the answer. That answer is provided back to the LLM, which will incorporate it in its reasoning to provide an answer, which answer is then sent back to the user. Now, all the arrows which you see in gray are happening behind the scenes, and they're not visible to the users. They're just an execution flow between the app and an LLM. Now, let's see if we can try these out. So first, we want to see, show me all the chats which you have available, all the tools which you have available for this chat. So we get quite a number of them, from currency by country to exchange rates to different MCP clients, temperature, weather forecast, finding articles in archives. So there are a number of tools which are available to us. So let's ask, we see currency as the first one. Let's say, what is the currency in Germany and what is the exchange rate to the US dollar? So we're asking two different questions, and there are two different functions, which we see. I didn't deploy it in a serverless environment in Cloud Run so that I can show you the logs easier. The application is running in Cloud Run as well. So we can see that it called two functions, and it tells us the currency is in euro, and here is the exchange rate. So the exchange server might be down, otherwise it wouldn't give us I don't think the euro and the US dollar are at parity today. But it tells us when it was updated the last time. So if we know how we have these functions, we need to know that these functions are not at all related to our enterprise data. They are just functions which we might call to execute different things. Now, don't see this as a chat. We just use it as a way to interact this. I like to call this app like a little postman for testing our Gemini application. We might also have, sometimes models might have a cutoff date. They might not be able to give us an answer. So if we ask which athlete won most medals at the Paris Olympics, a second set of tools which we can make available to an agent, and we're going to build slowly our tool chest up, is we had function calling. Now we can add also web search. Gemini models support web search, and so does SpringAI. So it will tell us I used web search, and it will tell us who won the most medals. But if I take web search off and I want to see it, it will tell me, well, these games have not occurred because the model's cutoff date was earlier than it knows that. So we have web search as the second tool in our arsenal to build our applications. our agents. So we have data, but these models are trained on various data, but they don't know anything about our enterprise data. So how should we think about retrieval-augmented generation? A user wants grounded, trustworthy information. So whether you pick a foundation model, a public domain one, a private one, or you fine-tune it, all of them have a time cutoff date. So we want to be able in enterprise application to access our data. It should be one, private access, and then the second thing, timely data. So we can use this pattern. What benefits do we get? Well, improved accuracy, having access to our enterprise data. Let's say we're querying the user manual of our car. We improve accuracy. We reduce hallucinations. Model base their data on up-to-date information. Up-to-date, let's not forget, in the enterprise means as often if we run batch process to update once a week, then it's as of once a week. If we do it daily or every hour, so we should not forget what was in the past in terms of updating data remains here the same. And explainability. We would know what models would bring to us. So how does the RAG work? We take a document, let's say we take a text document here. We split it into chunks. Large language models have large or small context windows. Gemini models, 1 million tokens. The majority have less. There are some with more. Even Gemini models will support more. So we chunk this in smaller pieces of data. For each chunk, and the way we chunk it is super important in the enterprise, and we're going to test that out as part of evaluation. Would calculate vector embeddings, numerical representation of these chunks, and which it would store in a multi-dimensional space in a vector database. Databases like AlloyDB, as well as all Google databases support vector capabilities. So if you have a Postgres database, you can use now easily vector capabilities. So we inject these chunks. That's great, but how would we actually make good use of them? Well, on the retrieval side, the user will send a prompt to a GenAI app, which will use a special text embedding model. We used here text to calculate the vector embeddings of our prompt. Very careful, the same model used for ingestion has to be used for retrieval, otherwise there will be discrepancies. Now, there will be a similar search in the vector database. Which vector, how is this vector, how do we find the one which is closest to it, the one with the shortest distance in this space? And we can retrieve a number of them, 1, 2, 10, I picked 5, for example, just for illustration. The chunks which were retrieved, together with a prompt, are sent to the LLM, which would inform its decision and build its answer. Now let's try this out and think a little bit. Let's go to another country. The data is all the capitals of the world, ingested from Wikipedia and chunked in various ways for us to test. So we're going to enable RAG, and from the various ingestion methods, we're going to pick the first one. If we use none, that means we can attach a document and send it. But here we do hierarchical chunking, so we break this up into sentences, and we take a number of sentences before and after that chunk, put them together and calculate an embedding. So it will tell us it's the capital of France and it has this population. How did we get to this number? I made this application show us its sources. It's configurable, so you can see its sources. So it picked 5 records, which are, we see the embedding, we see the actual context, and we see the distances. 0.62, 0.63, not bad, but it could be better. Should we have used a different type of ingestion? Well, if we use hypothetical, where we take for each chunk, generate 20 questions for that chunk. What would I ask if I have this chunk? What would I ask about it and store those? Then I want to see what kind of information I would get. So in here, it gives me closer distances. Well, 042, 048. Well, also not at that, but which one of them is the best for us? We have to think about how we're going to evaluate it. We're adding to this also something called query compression, where I'm asking two questions, and LM will decide how to reformulate that prompt. But I'm also going to add re-ranking. After we got the response, we want to use a scoring model which should tell us how close is that prompt with the data which we retrieve from the database. So in here, if we re-rank them, we're going to see, well, here's the process, but re-ranking did not retain any. How is this, how should we decide on that? So we are going to think about test-driven AI development, and now we should establish what the best test would be. The team at Vellum put this interesting diagram where they're talking about test-driven AI development. So we start from planning, we have to experiment across different models, which we can test, different prompts and different workflows, then evaluate the different prompts in different scenarios with different tools to see which one will meet the metrics and the criteria we set out. Then we deploy to production and constantly observe, track these execution so that we can fine-tune our solution. In general, a user would send a query to an AI service, which will prompt an LLM, great, gets a response, and there's an evaluation service. We can use a model to help us evaluate it, but we can also as well use libraries. We have to think about it from an evaluation framework perspective. What's the factual accuracy, context relevance, hallucination detection? We want to compare that with a test data set, and let's say what we have in the database could be a test set. Should you ingest all the enterprise data in various ways? No, but you should find for a representative one which one works, and then generate evaluation results. So let's try this out. Let me reset the entire app, and we are going to use query compression, and we're going to use re-ranking, and we're going to evaluate the RAG data. So I'm going to ask the same question, but I want it to go and retrieve the data for each one of them. So which one did I miss? Of course, maybe if I should enable RAG, that would be a good idea. And let's ask this again. So I wanted to look into the database, and I can see all the data which it captured. So hierarchical, well, it captured 5 and it retained 3. Hypothetical, retain nothing via re-ranking. So I've set a criteria of 0.6 as the similarity for the scoring model. So for the last two, it doesn't even need it. What do we observe here? While the distance, they're sorted by distance, re-ranking tells us that this response is the highest because the similarity score is the highest. And if we remember, when we ran it the first time, it tells us that in January 25, this is the actual or the closest to the population of Paris as we would know. Now, if we go and bring these all together and build now an agent with RAG capabilities, we want it to sync. This is the important thing for us. We want this to sync, and we're going to ask a goal. Population of Berlin, its geographic situation, historical origins. We send this prompt to an agent, and we're going to give it a system message with very clear instructions. Identify the topics, create questions, search in the database, collect the answer for each topic, and then generate a response. So the LLM will break it down into topics, and for each one, there will be multiple tool invocations. We don't know how many, not necessarily 3. We asked for 3 things, could be many. The LLM will decide how it will break it down. For each tool invocation, it will search in the database for that question. We use hypothetical embedding here, and it will call a smaller agent which knows how to summarize this topic. It could use a smaller model, if you maybe a smaller, more cost-effective model. It's as you choose. Now we get the topic report, and all of these reports are being added into a final response. But when we try this out, we want to actually change the system prompt. We want to change the system prompt as we just saw it in the slides, and we're going to give it the same system prompt. We're going to say use agents, and we're going to write a more comprehensive task. This would be write a report about the same things which we just tried to analyze, but we're going to ask we're interested in, we want to ask it, what is your thinking process? Before proceeding to call any tool, list the steps you have identified and the list of questions you ask the tools available to you. So it will tell us what the thought process is: identify the topics, devise question, execute the tools, and then questions I will ask these tools. Now I can use a different model. So let's say we use the Pro model, and we're going to see what kind of thought process this would have. The different model thinks a bit more. You see the response is slightly slower, but it will generate a lot more questions. And here are the specific questions which it's going to ask. So we can now go ahead. I'm going to be lazy and just copy this and delete this last part. Now we execute this in a sequential manner. Yes, it tells us to be patient. So I execute this sequentially just so that you can see the responses. So based on the info, it will first look at the population of Berlin, then it will ask us about the River Spree, which is in Berlin, the geographical coordinates. So we ask for three things, but it sets its task. It is not us who do that. And we are slowly going to get the response, and it will all be nicely aggregated into a response. But you saw we asked three things, we got our three things back, but that resulted in a lot more calls. Now, if we look at agents gave us access, and with Agentic RAG, they have access to our data. But that's our data. We're not going to, we have legacy data in the enterprise. We have maybe older databases, different types of data sources. We might not ingest them all into a vector database. So here comes the model context protocol. So if we look at data, what do we want? Sometimes we need more tools, we need more resources, and we need more context. So we had the REST, and REST API standardize how web clients interact with backend services. But for model context protocol, it's a new open protocol defined by Anthropic and released at the end of last year, which standardizes how the AI models will interact with different tools and data sources. Let's think in the old integration with REST. We have M clients and N sources. We might have an M times N situation writing an integration for each one. But here, to quote Anthropic, think about it as the USB-C for connecting devices to peripherals. We might have multiple clients to multiple tools, and we have USB in between them. Now, MCP capabilities are broken down between a client and a server. A server would expose tools which a client would use. It would expose resources. Let's say a resource could be our list of capitals of the world, or a list of users of our system, which a client can query for. Then a server can also give us prompt templates. Prompt templates and resources are not as well known as tools. Prompt templates would allow us to define prompts which a client could use, well thought of, clear prompts, high quality prompts which a user can consider to execute. And there are additional features. Sampling and routes. Sampling would be, let's think an MCP server might not know anything about AI, nothing. It just knows how to get some data, knows how to go and get some meteo data, and that's great. So if it knows how to do that, it might want to have additional information. So it will call the client and say, hey, you made these functions available to me. Please call this for me. You know about LLMs. Please call this and run this for me. And it would run it and provide the answer which the MCP server can provide. And routes would give us routes to a specific file system. Now, what transport do you have? You can host them within one application, and you can use standard I/O to access an MCP server, which could use local or remote resources. But I think that's a great use case, great for tools. You might have heard of all these tools available in all the coding assistants, in IDs. But for the enterprise, it's going to be a lot more interesting about our remote servers, where we have the ability at this time to use HTTP and SSE. That was in the initial protocol from November of last year, but it requires a stateful connection. In March, streamable HTTP was released, and when that will become available across frameworks, and SpringAI will support that, then you would be able to run post request and have stateless or stateful connections. Now, what is the life cycle? A client would reach out to a server, request a session, get its capabilities, and get a response with the server capabilities, and then confirm that yes, I have established a request session. Communication will ensue for as many operations as you want, and in the end, you would disconnect the client gracefully close the session. Now, with tools, we can request available tools, and we get the tools list. Now, let's try and run that. So, if we're going to look at tools, we're going to ask it what are all the capabilities which are available for the weather forecast service in Berlin. So we can see multiples. We can see some for getting temperature, executing prompts, listing prompts. When we register them, we can register MCP clients with the LLM, but we can register regular tools in which we can instantiate MCP clients. We might have a tool which might have to coordinate or orchestrate between multiple MCP servers. So you have both the ability of doing both. But if we want to see what are the MCP tools which are available to us, we want to list them all. So we see there are two: get temperature by location, we see the parameters, or we can see get the temperature by capital. So we can try this out and say what is the temperature in Berlin. It will reach out to Meteo service, and we expect it to come back with the temperature at this hour. So this was the last time it was posted was 2 hours ago, and it gave us some additional information, which I'm going to come back in a second. So we can run our tools, but we might as well run prompts. So when we run prompts, we want to see what prompts we have available. It's the same type of invocation, and when we look into prompts, we want to see a list of prompts which are available to us. So what kind of prompts do we have here? We have prompts for the weather forecast, for a climate overview, weather comparison, weather history. So we have these prompts, but when we see them, what we want to do is we want to preview them. We saw there was a tool for preview, so we want to prompt a weather comparison, and we expect to provide 2 locations and a time frame. So we're saying Berlin and Paris, and in a current time frame. So here is the prompt, and here's the prompt which it previewed for us. You're a weather analyst, compare the weather, focus on current conditions. That's what we ask. It's a good detailed prompt which is now made available to us and which we can run. But as we move, resources would be a similar way, so we're not going to demo that. But let's think about it. In an enterprise, tools change, prompts change, resources change. How should we know about it? So the MCP protocol allows for MCP notifications whenever there's a change on the MCP server side. We get a notification. We can then request the updated tools and get a list of updated tools or prompts or resources. Very important to us. Otherwise, what should we do? Should we try every hour, every month, every hour, every minute? What should we do? So we get we get notifications. It's more interesting to see then if we have this MCP server and we want to explore sampling, how would sampling work? So I already ran this. So I added the endpoint and I wired sampling so that it would also give us the average weather for the current month. We can run this again. This is just for our testing, and we would see how it will call this tool. It would reach out via sampling to the client, which would call an LLM, search for the information, and in the end we get a final response. Now, if we think about agent, everything we have seen, is this in our domain or should this be in a remote domain? So up to now, we could consider that the agents and the tools we had available are running in my own domain. I have the network, I can secure that, I can have a tourist bureau, I can have a currency agent, different MCP servers, but they're all running in my domain. MCP has a couple of features which are pending. One would be security, and the other one would be discoverability. So how should we think about connecting across domains? Let's say I look at Paris and I might want a ticket to, I don't know, an entrance ticket to the Louvre. And then I'm going to go to a different domain where I have a ticketing agent. And well, when I purchase a ticket, I might be running a payment agent. So what protocol should I use? So at Google Cloud Next, Google released the A2A protocol, the agent-to-agent protocol, which focuses on the collaboration between agents and not tools. So it supports agent discovery. Then it's secure by default with authentication authorization mechanisms. It builds on existing standards. It's like MCP, built on JSON RPC 2.0, facilitates short and longer running tasks, and it is modality agnostic, not just text. It could be also video, or could also be sound. So the two most important things are, like, how do we actually get the capability of an agent? So the agent is described by an agent JSON file, which is always located at a well-known location in every single agent. If we deploy this and we have the endpoints, if we query each one of these agents, we should know that we get this agent JSON file, which should describe things for us. It will tell us what authentication scheme it would use, input and output modes, if supports streaming or push notifications, a name and a description. But also it would define in the protocol a number of skills and supported formats and authentication. So for example, application HTML and video MP4. Now if we were to compare them, they complement each other, right? Both of them are protocols for the agent ecosystem and they aim for interoperability. We have to think that MCP focuses on standardizing LLM and tool communication inside the same domain, whereas A2A focuses across domains. Nothing prevents you from running A2A within the same domain, but let's create this delineation. MCP focuses on the capabilities of a single agent, whereas A2A will enhance the coordination and delegation of many agents. Now, while MCP exposes tools and resources and prompts and sampling and routes, A2A will expose capabilities via agent card. MCP has no dedicated auth or specified discovery at this time, whereas OAuth 2 can be used for authentication in A2A, and the agent JSON is at a well-known location. That does not mean that it we will discover it. One interesting thing which you might consider is using an MCP server as a discovery server for known endpoints of remote agents. If we have deployed them all in, say, serverless Cloud Run, we have all the URLs, and an MCP server would be able to retrieve, for example, a number of services at that particular URL. This is just one option. There will be different options in the future. Let's think about like the idea of a service registry, where a service would be posting itself. I am up, I am known here, and oh, I'm a client, I'm going to look for this particular information. Now, when we build a Gen AI platform, we start from a simple. Here's a user, use an LLM generation, but then we add things like RAG and agents and query rewriting, and we retrieve read-only data from different sources and vector databases. And then what should be our next thing? Should be guardrails. So guardrails would allow us to prevent PII data to leak, for example. We don't want to send our personal information to a model. And as well, we don't want to allow users to ask inappropriate questions. It also helps guard us on unauthorized types of responses. But if we get malicious content or something inappropriate or uncomfortable. So guardrails are a must for us. How should we try them? How should we try them out? Now, we can try them out in various ways, and we can enforce them. What we want to do is Gemini models allow you to have safety settings on and off, and for each one, what you want to block, at which level you would want to block. But what we want to run is we want to say, recommend a good prompt to test this application with safety settings turned off, respectively on. We don't want to ask an inappropriate question in a conference session, but we want an LLM to tell us, how should I test with these kind of answers. So it will tell us what would be expected behavior for testing, at which level we could do that. It's a very clear answer which we get in terms of how we should think about it. If we ask thinking models how we should ask these questions, we might get a different response. It will take its time to think about it, and then it would build a response. It will build a response for us. So it will tell us now. It will recommend some specific ones. This is world capitals and geography. So there are some which are safe to test with safety settings turned on and off. You can, of course, try these things out and do so. I will just show you how to think about it, but I'm not going to run through them. So in the end, we use the LLMs also for scoring and for routing different LLMs and help with evaluation. But we also have to think about performance. We might repeat the same prompt, or we might have one large document. We want to ask 10 different questions about it. So if we did that, how should we always send the same document? So we can cache that. We can explicitly cache that. Gemini models support prompt caching. But recently, a few days ago, implicit caching was released. So if you're asking similar questions, it will cache the responses, which will decrease your cost significantly, because you're not going to send the same information and your token count will be a lot lower. Now, the next thing would be observability. We should have put it at the beginning, but it makes more sense to see that at the end when all the components are on the table. And last thing is something which you should think 7 times before you do it. Write actions. Should we allow an agent to act on our behalf? Should we allow it to write an email? Should it send a message on our behalf, modify a database? That's something we need to understand the use case, test it thoroughly, and see where this goes. Before we look into pitfalls, I'd like to run this one more time, just so that we can bring together the test which we ran here. I'm going to run this model, and I'm going to ask an agent, just so that we can observe the complexity of what agents would do. And we're going to ask multiple reports and ask information about multiple MCP servers. The Java MCP implementation was built by the Spring team and donated by Anthropic. Christian, if he is around, he is the man who did it, and he has a session tomorrow, which I would highly recommend to listen to MCP from A to Z from the man himself. And I want you to think about this. We want to have agents we set them a goal, they have different tools, we want them to think about things, we want to call different tools, execute until the notion of done has been achieved. That's what we are thinking about. Now, when we go to production, we always have some pitfalls. Nothing comes in really for free. Should you just consider everything is just simple and easy? Well, not as much. Think that Gen AI, use it when you actually, one of the pitfalls is using it when you actually don't need it. So let's be reminded that Gen AI adoption is driven by business needs, not by technological aspects. The second thing is conflating a bad product user experience with a bad AI. So starting to use Gen AI is easy. Bringing a good production is the hard part. This demo app, is this like an evaluation tool? It's a tool for us to evolve, to play, to test things out. But I won't post this up for a large audience to try things out. Should an organization build such maybe app for their own evaluation? Yes, but build it, test it before you put that in production. Also, starting with a complex solution rather than an evolutionary architecture is always like a decision to be avoided. Like, for example, you want to use an agentic framework when you have a simple workflow or just 3 direct API calls. Agentic frameworks are great things, but use them if the complexity of your application calls for that. Then the last 3 would be being optimistic that an initial demo success translates directly to production greatness. We have to think from the beginning about reliability and safety and security from day one, not on day 2. Let's think we build this even as an internal app, and suddenly an entire organization uses it, and we forget to enable safe guardrails. I don't really want to be on that day when the first problems occur. I don't want to be around that. The next one would be relying entirely on AI as a judge, as a substitute for human evaluation, with more information, more effort. We want to correlate human judgment with AI judgment. But if they are divergent, investigate always the AI judge. It's our responsibility as humans to fine-tune our system. The last one would be our failure to continuously evaluate and gather feedback from our system. Models change. When a model changes, use the model to the latest, pin the model. Each thing changes. When something changes, test again. When your data changes, test it again. When your user use that, test that again, and use the feedback to evolve. One feature for developers, which Google released 2 days ago during Google I/O, is up to now you have the Vertex SDK. To use it, you need credentials. It's a secure way, it's great for production, but developers have asked for access with an API key. Use it with an API key if you choose to do so in your local environment, and then use credentials when you go to production. The Unified SDK was released 2 days ago, and it's going to be available in SpringAI pretty soon. So thank you for listening or watching this. I know I went all the way up to time, but if you have any questions, I'll be hanging around, and in the end, attention is all you need.